Hi, this is Mr. Foley. This video is on how we can use the kinematics equations to actually solve problems dealing with accelerated motion. As discussed in another presentation, there are 5 equations needed to completely describe the relationship between the 5 quantities involved with moving objects. And again, those 5 quantities are initial velocity, final velocity, time, displacement, and acceleration. So we wind up with 5 different equations. Acceleration is equal to Vf minus Vi divided by t. Vf is equal to Vi plus At, which is really the same equation, just rearranged. Vf squared is equal to Vi squared plus 2a delta x, or 2a times displacement. Displacement, or delta x, is equal to 1/2 Vf plus Vi times t. And delta x, or displacement, equals Vit plus 1/2 At squared. Now if you look at these equations carefully, you'll notice that each one only has 4 quantities in it, which means that each equation is missing one of the quantities. And that's going to be very helpful when it comes to choosing which equation to use. As with all problem solving, it's important to get in the habit of following a few steps and just doing the same thing over and over again. So to use these equations to solve problems, here are the steps we're going to follow. As always, the first step is reading the problem carefully. Most errors occur simply because the problem's not read right. Step 2 is decide which quantity is wanted, because you can only solve for one quantity at a time, which quantities are given, and most important, which quantity is not involved. As you set this up, the way I usually do it is I put a question mark next to the quantity that's wanted, and then I put X's in the quantity that's not involved, just to keep track of those. Step 3, you're going to choose the equation that's needed based on the quantities involved. You can only use an equation that involves the quantities that are involved in the problem. And then, of course, you may need to rearrange the equation if necessary. Step 4 is where we get into the calculation. This is where you're going to take the numbers and plug them into the equation, making sure they fit into the right slots. And then you're going to use your calculator to solve. Your calculator does not come out until you get everything else set up. Then you're just going to check for units and significant digits in your answer. Remember, don't write down anything unless you have a reason for doing it. And then finally, step 5, always a good thing, check for the reasonableness of your answer. There are 2 important rules to make life easier, and these rules are extremely important because we have to decide what signs we're going to put on velocity and acceleration. So here are the 2 rules. It's really important that you learn these and use them. The first rule is simply make the direction the object is traveling first the positive direction and positive velocity. And so if the object is moving up first, make up the positive direction and make that the positive velocity, which means if the object is coming down, it's going to have a negative direction and a negative velocity. And you'll determine that by what your answer is. If the sign of the answer changes, for example, if the sign of the velocity changes, you know the object has changed direction. So always make the direction the object is traveling first the positive direction. Number 2 deals with acceleration. If the object speeds up first, make the acceleration positive. If the object slows down first, make the acceleration negative. And so it's kind of important to keep that in mind. If an object is going downhill, well, you know it's going to speed up first, and so make the acceleration positive. On the other hand, if the object starts by going uphill, like rolling a ball up a ramp, then anything going up, whether it's straight up or up a ramp, is going to slow down. And if the object slows down, make the acceleration negative. It's very important when you use the equations then to keep track of those signs. You can't lose them in your calculations. If the acceleration is negative, make sure that you make the acceleration negative when you do calculations. So here's an example. A ball falls from rest with an acceleration of 10 meters per second squared for 15 seconds. What is its final velocity? So we've read the problem carefully, and so now we're going to go through and we're going to list our variables. It's a good habit to get into to just always list your variables in the same order. That way you know you're not forgetting any. Acceleration in this case is positive 10 meters per second squared. It's positive because the ball is falling, so we know that it's speeding up first, so we make our acceleration positive. Our initial velocity is 0 because it's falling from rest. We're being asked to find the final velocity, so that's what we want, and so notice that I put a question mark in there. The time is given as 15 seconds, so I put that in there. Now, the displacement is not mentioned, it's not needed, it's not involved at all. And so we put X's in there just to know that's what's not needed. So in this problem, we needed an equation that has acceleration, initial velocity, final velocity, and time, but doesn't have displacement in it. And so that equation is VF equals VI plus AT. Now, because we know the initial velocity is 0, when we write down the equation, we can just leave that initial velocity out because we know it's going to be 0. And so it's just VF equals AT. In the next step, we substitute in our numbers. So our acceleration is 10 meters per second squared times 15 seconds, and that gives us a final velocity of 150 meters per second. If you follow through these steps each and every time, and keep very careful track of your signs and understand what the signs mean. For example, if the velocities change sign, they change direction, then these problems should not be very, very difficult. The trickiest part for most people is rearranging the equation. And so if that turns out to be an issue, then you know what you should do. Come in for extra help. I hope this video was helpful. It's uploaded to Classroom, and so you can always go back and look at it. Thank you for your attention.